Welcome back to the greenhouse, everybody. We're going to be discussing the cheapest, most sustainable heating methods for your greenhouse. This may be a bit repetitive for our longtime subscribers, but we've got a lot of new people on board and we're hoping to find more. So we wanted to share all these methods of how we're heating our greenhouse. And there's four main methods. There's four core heating methods that we religiously use and we're operating in our greenhouse at this very moment. So without further ado, if you guys find this stuff interesting, please consider subscribing, hit the like button. So first things first, let's discuss passive heating, passive and solar. So I consider, and I coined this term, you got passive heating and you've got active heating. So we're using energy from the sun in a lot of ways in this greenhouse, simply creating microclimates throughout the entire greenhouse. I mean, the entire greenhouse is a microclimate. We have all of our open floor, the bricks. It's very warm in here from a sunny day. We're sitting maybe 18 degrees Fahrenheit outside right now, not too windy. We've been sprouting all of these little leaks sitting on top of this mass of water. So this releases its heat throughout the night, obviously straight up. So that is just one simple solution, having thermal mass, heating it up with the sun, having black pigment, very dark pigment, always draws more energy into it. We've got this black brick right here, sitting 65, and then the soil next to it, it's kind of more in the shade, but it's 59, 61. This is in the sun, 58. So just by painting that brick black, actually it's just burnt up. That just really goes to show the difference in temperature immediately. Now, if you have an ideal location where you're setting up a microclimate or a heater box or attempting to heat that black pigment, you are going to have better success. You can have 10 to 15 degrees above that temperature. See, we got lots of sprouts popping up here. It's hard to see them. We just broke through a polar vortex. Everything survived. We actually let the plants dry out a little bit too much. We have a little bit of yellowing. The edges were drying out. So we ended up coming in here and throwing a bunch of ice in here, and it may have caused a little bit of cold damage also. But all of that ice melted up and we were able to get moisture, much needed moisture to these plants in winter. Everything's still alive. We're showing sprouts. This little microclimate here, as we pull our polytunnels over, creates a nice little warm environment and it holds the heat closer to the ground than the 7.5 foot ceiling. So it just goes to show we've got 70 degrees in here, but I do have a fire going. My son had started some muffins down there, some banana nut muffins cooking right in the greenhouse. So needless to say, creating those sunny little microclimates really benefits a lot of crops, especially if you're trying to start. You just have to watch moisture levels in winter. Let's move on from the natural passive heating, just using the natural sun as it comes in to heat certain things up more than others and try and store that heat in thermal mass and things like that and bricks. So going from a passive source, we're going to talk about some active heating on a solar system. So this bad boy is an experiment and we're not actually going to operate, take data or anything from that today. It's just freaking cool. It's a nice little contraption me and my son have built together in the garage here. Now we've got this large tank back here. That is another experiment. We're going to be planning on heating that. We're going to be running the sun through the solar panel outside, running the electricity through the panel. So turning the energy from the sun to electricity and then turning it to heat for a thermal mass, all running for free off of the sun, minus your initial investment of a solar panel. So this is hooked up to a solar system also. We're going to click the on button. And with the on button comes on our radiator fans. And as soon as I touch our little motor speed controller, we will watch the water levels drop. And it starts feeding into the system here. So I really don't like to build closed loop systems, but I could get away with it because we make our own DIY coolant and thermal mass solution. So it's got a very low freeze point. We've got a couple heater elements. Now this is all controlled off electricity, 300 watt. This one is like 30 to 100 watts. So lots of cool experiments coming with the solar power heating systems. So that solar power is super important to us in the greenhouse. We've got about 500 watts of solar power. Can be quite a big investment off the bat, getting set up, getting correct batteries. And we don't even use the correct batteries most of the time. We're just using recycled batteries and doing what we can with what we have as cheap as possible. So all of the other systems in this greenhouse are operating off solar power too. So not only are we heating, we're moving water, we're doing lots of things. This little pump here, the pump and the battery box and the timer and everything, just using a tiny little check valve to keep the water flow on a small pump kind of filled up. So we kept our lines filled up. I'll show a little clip of the solar heater we had. That was all free energy, ran off the sun, pumping energy into this tank, but the shade that it created kind of negatively affected it. So I would rather just have the sun shine directly on the water for now till I get some other system to heat this tank up. So let's move right on to the second system that I use to heat our greenhouse. And technically this system can be used to heat and cool a greenhouse. So coming right down to our geothermal tubes, I'm gonna put the microphone up just so you can hear it running. So we ran ourselves these geothermal tubes. This is just a Y pipe and I've got covers. Now we're blowing 53, about 53, 54 degrees, 56 on the metal. So we're constantly putting these temperatures right to the floor in this bed here. We ran ourselves about 85 feet of pipe coming down from this underneath the center of the walkway, about 8 feet down, completely hand dug. And then it starts to slope back up and then it curves over right to the intake. We're just using a simple 12-volt solar fan. It uses like 3 watts per hour or something. We've got another fan back behind our stove that we operate off the same system, which it wasn't on. I had to click it on, but we've got our compost heating fan also. That is another subject, but we've got many fans running off of just one solar powered system. We also use our free energy Peltier device. That is a bit of an investment. That one was like 30, 40 bucks. My son had made some muffins. I don't know where he went. I'm gonna go ahead and pull them out for him because they are done. Got a nice snack I gotta let cool off on some bricks here. Nothing like cooling the muffins next to the greenhouse pond. Anyways, the greenhouse pond is a geothermal pond itself. Now this thing is about 4 feet deep, so technically it's not a geothermal pond on its own. Its pump and the lines that feed this waterfall are running out through our compost pile. It is very low on the compost pile, so it's really not getting an active heating. It did right at first when the whole entire pile was hot, but we'll create a nice insulating layer of 1 foot or 2 at the bottom of the pile. So up above that level, the center will be cooking nice and hot and sharing residual heat. But for the most part, I was attempting to get 50 to 70 degrees into this pond throughout the winter. So far, we haven't had a freeze up. We've had good success, and we are basically operating this as a geothermal pond. If you're able to, digging down and running water through the ground, or running lines, running air, running water through a decaying heap of wood chips will definitely insulate it, just like geothermal through the winter time. All right, so our pond is sitting 54 degrees. Oh. So at 54 degrees, these fish are totally fine. These fish could handle probably a good freeze over the surface. So we've had pretty good success with this experiment this year, and all of this is ran off of solar power. Our pump is running off solar power back on our far wall. Everything in here except our grow lights are ran off solar power. These are too much draw. I am in the process of building a bigger bank so I could run these off solar power also and have absolutely no bill whatsoever. We're spending about $10 a month to $16 a month just to operate these lights, and they've really helped us out quite a bit. This end of the greenhouse has been pretty sparse. It was just a transplant and last minute bed. So we hit passive heating and a lot of experiments that come with that. We've hit geothermal and some experiments that come with that. Let's move on to our greenhouse stove. Just a quick observation here. You can see all the fish that keep hanging out in the low spot where our compost heating line, that PEX, that blue tubing, is sitting. They like to sit right underneath it because that's the warmest spot in the pond. Coming up to eat some food here. There is 100 ways from Sunday to be able to experiment with a greenhouse stove and heat your greenhouse. I mean, simply using it for its purpose, it's going to do its job. Adding a bunch of brick thermal mass around it is going to really help it with its job. It's going to hold a lot more heat around it for a longer period of time. And then you can start experimenting. You can add ovens, you can add fans, you can add a blower on your exhaust pipe. We didn't have the option because there wasn't too much exhaust pipe to work with in here. You can wrap copper around it. You got to worry about the outdoor use of copper and water together. We've blown up a few copper pipes trying to heat with the greenhouse stove, using a bucket full of sand and transferring all of that heat through the copper and running the water with solar power only back into our tank and heating it up with the wood stove, adding a ton of thermal mass. So not only can you just burn on a wood stove, there is a lot of extras that you can be doing with the heat and moving the heat and storing the heat simply just by having the one system in place. Now this is a little bit more monetary and it's a little bit more involved. It's not just going to operate like a solar powered geothermal system, and it's not going to heat itself up. It's not going to stoke itself, and it's not going to put wood in itself. Quite a bit of work when using a wood stove for the only heating source. That is why we have many methods, and on the very cold nights we will come out and we will burn this sucker as hot as we can get it for as long as we can stand, and then we'll head back inside and we survive every negative temperature that we've seen. So I'll reiterate that it can be costly. You gotta buy a stove, you've gotta buy all the pieces to make it operate. If it doesn't have a damper in the flue pipe and it doesn't have a flue pipe, you have to run and route the exhaust, which can be quite costly. But it's a decent investment that is well worth it, just like any other system that I've mentioned. They are well worth the input you give to get in return. So a decent cost and a lot of maintenance and work involved. Wood stove is probably the least sustainable, I would say. I mean, wood's free if you can get it for free. So it can go either way. Depending on your situation, we like to reuse and recycle as everything we can. So where we can save costs, we can use costs and invest into other systems. Now, my favorite heating system and the fourth and final sustainable and cheapest heating system is compost heating. My favorite here. So we've got our water running. Pushing about 74 on the dot. So that's not super warm. It's been running all day and we've got some cold temperatures outside. So we do see fluctuations. It's compost. It's going to go up, it's going to go down. And in the really, really cold temperatures, we shut the water off sometimes and we'll just run the air because it is a much less draw and we want to keep that pile active. Oh, where are we sitting at here? About 75. About 75 on the dot coming out of our air tube. So we're blowing 75-degree air in. We've got a fire going. We've got a little bit of sunlight. It's comfortable in here. All these plants are flourishing. It's very nice to be able to come out here and get little things done, plant stuff, throw seed, do whatever I have to do out here and not have to worry about the heating systems. If we want to fire, we want to bake something, we want to eat, we can do that. I don't have to come out here and touch anything. Systems all run autonomously, which is absolutely great in my book, and I'm not having an electric bill by running them off solar power. We've got ourselves a little windmill we want to set up that is worth 500 watts. So we could basically double our input on a super windy day. Now, I really wanted to catch this while it was operating, so we had some water flow temperatures, got our air moving, just a mangled mess of solar power, but she works well. Suppose I should go find my son, tell him his muffins are done. He's probably out there shooting his BB gun somewhere. And with that, that's pretty much it for this video, guys. So I ran through this pretty swiftly, short and sweet. I wanted to show everybody all the little experiments, give everybody ideas, and inspire people. Now, I know there'll be questions because I didn't go super in-depth on every little topic. So everything I covered, if there's any questions, definitely drop them to me in the comments below. We've got hundreds and hundreds of comments to get to. You guys are awesome with your ideas, suggestions. We really appreciate you guys. Thank you very much. We've got some cool reveals that you guys have helped us achieve. So lots of cool stuff coming in the future here. Thank you guys for watching this video, and I'll see you in the next one.